Section 12.5b is about dividing polynomials by binomials. So no longer are these monomials. What we want to do is we want to start by rewriting it as a fraction. I think that's easier to look at it. This can be fairly complicated unless one of these will factor. And if you look at this trinomial, we want to use the diamond and try to see if that trinomial factors. So are there two factors of -7 that add to be a 6? And the answer is yes, +7 and -1. So if you can factor that trinomial, that would be great, because now look what happens. The s plus 7s will cancel, leaving me with an answer of s minus 1. That's not going to happen every time. Sometimes you're going to have to do something called long division, like in the next example, but you should always try to factor the trinomials, because if you can, you'll save yourself a lot of work. Here's another example of dividing by a polynomial. I'll rewrite it again just because I said you might want to do that every time. Now, if we could factor the top, that would really help us out. Can you think of two factors of 24 that add to be a 3? Well, the first thing that comes to mind is 8 and 3, but that won't give me a 3. 12 and a 2 won't work. I can't think of any two factors of 24, -24, that add to be 3. Even 6 and 4 won't do the trick there. So the point is, we're going to have to do something called long division. We're going to have to go back to grade school. So we are going to take the x squared plus 3x minus 24, and we're going to have to divide that by x minus 4. And so here's how you do that. So you start with the x in the front, and you ask yourself, how many x's are in x squared? In other words, x times what gives you x squared? And the answer is x. Now I'm going to put my answer here, because when you do division, you try to keep your columns lined up, which means this is the squared column, this is the x column, and then this will be the number or the constant column. So keep those columns lined up. Now, just like in regular long division, you multiply x times x, and you multiply x times -4. And you always subtract. So we'll get a 0 here, and we'll get a 3 minus negative. Minus a negative is a plus, so that gives me a 7x, and now you do like you normally would in division, you bring down the 24. So, x times what gives me 7x? Answer is +7. Notice it goes in the numeric column, or the constant column. 7 times x is 7x. 7 times -4, -28. Again, always subtract. Subtract those, you get a 0, which is what you want to happen. -24 minus a negative, that's a plus. So we're going to get a +4. Now here's where we got a remainder. And I'm going to show you how to write this. So x minus 4 is going to go into this trinomial x plus 7 times, but then we're going to write this remainder, but the remainder has yet to be divided by x minus 4. So we write the remainder as this value here, 4, divided by the x minus 4 that's out in front. And this is as far as you can divide these two polynomials. Here's another example of dividing polynomials, and I can rewrite this as a minus 2. Now we'd like to factor the top, but first thing I notice is we can't, because this is an a cubed, and we're not used to seeing a cubed. So we're going to have to do long division, but if you notice the heading here, it says missing terms. When you do long division, and I'm going to begin by writing it down here, you have to make sure that you have all the terms accounted for. So when I write my trinomial out, I'll start with an a cubed, but if you notice there's no a squared. But I have to have an a squared value when I write it out. So I can finish with 8a minus 24, but I got to figure out a way of writing an a squared term in there just so my division can be organized and can work out. So how I'm going to do that is I'm going to use 0 a squared, because that's a way of writing an a squared term that really doesn't exist. And now we'll use long division. A times what is a cubed? Answer is a squared. Notice I'm writing it in the a squared column. A squared times a is a cubed. a squared times negative 2, negative 2a squared, subtract. 0 minus a negative, that's the same as a plus, so we're going to get a positive 2a squared. Bring down the 8a. A times what is 2a squared? The answer is 2a. So 2a times a is 2a squared. 2a times negative 2 is negative 4a. Always subtract. So 8 minus a negative, that's a plus. 8 plus 4 is 12. Bring down the minus 24. A times what is 12a? Answer is 12. 12 times a is 12a. 12 times negative 2 is negative 24. Always subtract. 0, 0. So it turns out here that we don't get any remainder at all. So my solution when I divide these two is a squared plus 2a plus 12. Now we would not have been able to find that because we could not have factored that trinomial because it's not really a trinomial. So using long division, sometimes you might have to put a missing term in, and when you do that you're going to use a 0.